So far we've been looking at functions that have been what we would call smooth, which means we've been looking at functions that have nice curves on them. For example, we might have looked at a function that looks like this, something curvy, or we've been looking at functions that have been straight lines. Now, not all functions are smooth like these functions. I have an example here of a function that's not smooth. This is a really bad scan of the function, but you can see the graph on page 125 of your book, which is where I took the picture from. So this function is not smooth. So this function is not smooth. It has sharp corners and a break in the function. And you can see that here it has a sharp corner at the point 2,3 and a break here when x is equal to 5, and so it's not smooth like the ones we've been looking at before. And so these functions like this have to be defined in pieces or in parts. So these functions have to be defined in smooth pieces. So if we look at this function here, we can identify 3 smooth pieces of the function. So our first smooth piece goes up to x is equal to 2. It starts at x is equal to 0. So here we can say that f of x is equal to, first of all, for when x is greater than or equal to 0, but less than or equal to 2, we need to then find the equation of this line. So this we can see is a linear function. It's a straight line, or at least it should be, and it would be if the scan were better. And you can see that every time we go along 1, we go up a little bit. If we go along 2, we go up 3. So if we went along 1, we'd go up 1.5. So here we'd have 1.5 times x, because it's a straight line with a gradient of 1.5, which can be found either with the difference quotient or with similar triangles. And that's the first element of our piecewise function here. And we use these curly brackets, and I would recommend writing them by doing a kind of long S here, and then mimicking that long S at the bottom. So that's part number 1. Part number 2, I'll take a different colour for. So part number 2 we can see is this middle part here, when x is 2 to when x is 5. And we can say here that then between 2 and 5 we have a different function. You can see I haven't included 2 here, because 2 is included there, and if it was included here as well, then it would be as though we had 2 points on the function. When x is equal to 2, which would of course wouldn't make it a function anymore. But I mean, that's just convention really. I could have not included the 2 here and included the 2 there. So now we need an equation for this line here. Well, we can see here that we've got 3 on the y-axis, and actually f of x, the value of the function, is 3 at all points along this part. So f of x is just equal to 3 here. Then we have a third part of the function, which is then this bit here. So this is when from x is 5 to when x is 7. And again, I've just made sure that I haven't covered the 0.5 twice. And here again, we have a linear equation, and we can find the gradient by taking a look at how long we go up each time we go across. So here the gradient's going to be a half, so 0.5x. And I can find the plus c or plus d by putting in one of the points on the function. So here we have 5, 4. So the 0.54 lies on this. This is x, this is y. So 4 is equal to 0.5 times 5 plus d. So 4 is equal to 2.5 plus d. So d is equal to 1.5. I've just taken 2.5 off there. So plus 1.5. And this is how piecewise functions are defined. That you take the different pieces, you make sure they don't overlap, and you have the definitions written here. So let's look at a second example. Again on page 125, this time you're given the function, the equation of the function for a piecewise function, and you have to draw the function. So what you're given here is you're given that f of x is equal to, and then we've got our curly brackets again, minus 3 for x is less than 0, f of x is 0 for x is equal to 0, and x plus 1 for x is greater than 0. So, if you draw yourself a set of axes, yours I'm hoping will be much, much neater than mine, because I can't do particularly good graphs with the equipment that I use here. So first of all, we have a look at x being less than 0. So here we can say that the y value here is always negative 3. So if you have negative 3 on your y-axis, and hopefully you've used a ruler for this, I can do a straight line to show this. So the graph of the function is at minus 3 up to, but not including 0. So to show that it doesn't include 0, you can end this line with an empty circle to show that it doesn't include 0. It's 0 then for x is equal to 0, so when x is equal to 0, the value of the function is 0. So we can do a filled in circle to show that that's a point. And then for x is greater than 0, we have f of x is equal to x plus 1. So of course this will cross the y-axis at 1, but it doesn't actually cross the y-axis because this point isn't included. And then it will carry on from that point with a gradient of 1. So every time you go along 1, it goes up 1. So your line, if your scales are the same, should be a little bit steeper than this. So you can see then how we can go from the equation of a piecewise function to the graph of a piecewise function. And to make sure you've got this, I'd like you to try 2 exercises on your own, and we'll take a look at the solutions together in class. The first one is exercise 398. There are parts A and B to that I'd like you to try. And also exercise 401, again both parts. This one takes you from the equation to the graph, and this one from the graph to the equation. If you have any questions, as always, please either note them down in your book or ask them in the next class. And then, with this video and these exercises, we've finished our work on linear functions, and so it will be time to move on soon to quadratic functions, which are a little bit more exciting. We're moving out of the realm of straight lines. So to be able to recap a little bit of knowledge that you've already acquired about quadratic functions, I'd like you to do exercise 418, all parts of that one, and finally exercise 420, which involves figuring out some coordinates for the graphs, for the functions that have been given, so that you can then match them to their graphs. So please try these 4, and we'll discuss them next time. And then please come ready to start our module on quadratic functions.